I'm going to start a little bit philosophically here and then work into something very technical. I have come to believe that we are not designed to live as hierarchical beings, that every person is infinitely valuable and no one is any more or less valuable or important than anyone else. So that view has gotten me in trouble more than once, especially when I've stood up for someone that someone who was important thought was one of the little people. But if that belief is true, then it's not just a courtesy for me to learn something about you. It's a necessity before we can communicate. So I'd like to ask you a few questions, learn something about you, and then move into what we're talking about. My first question is, how many of here would call yourselves software developers? Okay, great. How many of you would call yourselves managers of software development? Okay, great. How many don't fit in either of those categories? That's great. Can some of you who don't fit in either of those categories just kind of call out what it is that you do?
Talk about it.
Maybe in a 2 or 3 word phrase.
Systems assurance.
Systems, excellent, excellent. Yeah, very important.
Systems architecture.
Systems architecture, all right.
Process improvement.
Process improvement, excellent. Sort of a Demingite among us, maybe? A little bit? Yes?
Programming language designer.
Excellent, okay. Fascinating. Anybody else want to call one out real quick? Okay. Let's go on to something a little bit deeper then. How many of you love software development? Excellent. Okay, so how many of you love the reality of developing software as much as you love the idea of developing software? It's a much smaller sample there. This is just as I thought. The idea of developing software is beautiful. You know, it's very elegant. Sometimes the reality of developing software, though, can be brutal, can't it? Especially when you're on a failed project. Do you remember the worst project that you've ever been on? Do you remember what it was like? Do you remember what it was like when the alarm would go off in the morning, you'd look at the alarm and think, oh my, I've got to go back to work today. Do you remember, were the people, when you got there, were the people smiling at each other? What was the tone of the office? Were people eager to push credit off on someone else, even if they deserved a piece of it? In that environment, it's kind of every person for themselves, isn't it? Dog eat dog. So the negatives of a failed program hurt everyone. And this is the reason why I'm so passionate about making projects successful. This has been the theme of my career all the way through. Because successful projects are good for people. They're good for you, they're good for me, and they're good for everyone out there that we are serving with our work. So with that, we'll go into the technical content here. Do y'all remember what we used to call the software crisis? Back in the 80s and 90s, that's how we called the projects being late, being over budget, and not satisfying our customers. Back in those days, in those bad old days, we were told by primarily the Standish Group, who kept the statistics on this, that only 25% of all projects were successful. Well, let's see how things are today. The same group tells us that there's been a stunning improvement. This is as of 2007, the latest report. Well, what does a stunning improvement mean? Well, it means we've gone from 25% successful all the way up to 35% successful. Well, I don't know about you, but when I took my second grade elementary school sums, 35% successful was the same thing as 65% unsuccessful. 2 out of every 3 projects are still unsuccessful. Now, the same people also gathered the data to tell us that when a customer spent 100 cents on software, they got 59 cents worth of value. Well, in 4th grade, my class in division taught me that that kind of a ratio means that they are overpaying by 70%. So, the irony is that this problem has already been solved. There are organizations right now that set out to have successful projects, and by golly, they have successful projects, beginning to end. Rod Chapman and Praxis, good example. They've got a number of those. So it can be done. The problem has already been solved. And in fact, I would say it's outrageous that in our industry that we still tolerate this kind of performance when the problem has been solved. Now, W. Edwards Deming, the quality guru, used to say that the buck stops at the door of senior management. In the U.S., we would say that those are the people that get the multi-million-dollar bonuses, like at AIG. Those are the people who can do something about it. The people that are in this room, by and large, it's difficult for us to leverage that, especially if we work for large companies. But it can be solved. And those folks, I believe, shouldn't take another luxury vacation and should not take another $1 million bonus until the problem is solved in their organizations. It can be done. Okay, so why do programs fail or projects fail? Well, it really boils down to something very simple. It boils down to the amount of cost to develop, the amount of value delivered. When you start out, you spend less to develop the worth of the value delivered to your customers, but at some point, if the cost goes above the value, then you don't have a viable project anymore. If you can't get customers to pay you what it cost you to develop your software, your project, you either end the project or you start subsidizing the project from your other revenues. Neither of those is a viable business case. In this article, they gave 3 specific cases of causes for the cost going exponential. And I'm not going to belabor that. You've got that in your notes. You can look at it. But each of those actually has a reflection in the choice of programming language. So the key here is, however you do it, you have to prevent the cost of development from going exponential. I thought this was a good quote, that when you choose the wrong language, that can do you in. There have been a number of big projects, though, that could never be successfully integrated. The advanced automation system software, for instance, was never successfully integrated. Now, that was the biggest debacle in the history of software development. $3.7 billion spent over many, many years. And there's many reasons why that project went wrong. But one of the reasons was that it could not be integrated. So integration, again, is a characteristic, or support for integration is a characteristic of programming languages. Let's look at some ways to pick a programming language. So here's a good way to pick a language. Whatever's cool. You ever seen that done? Or how about find the people that think of programming as a craft, like, basket weaving or pottery making, and let them make the choice for you. That's another way to do it. Here's a personal favorite, the mafia approach, extortion. Oops. Here we go. Use our favorite language or we'll make you hurt. That's actually, I have seen that one in action back in the dot-com boom. Either you use the dot-com language, which will remain unnamed at this point, or we're out of here. So we caved. We gave them the dot-com language. They went. 2 years later, their companies were all history, and they came back. But we were still using the dot-com language. Or finally, just maybe you can find somebody who picks a language because it's in the best interests of the business in the project. You never know. It could happen. Now, the fact of the matter is that the choice of programming language is not the biggest factor in the success or failure of projects. Studies have shown consistently that the biggest factors are poor requirements and poor management. However, poor requirements, poor management, and the wrong choice of programming language all boil down to the same thing, and that is bad decision making. And bad decision making is something that we don't have to live with, because decision making has been studied for decades, and there's a big body of theory. It's at the heart of the discipline that we call systems engineering. So I'm going to dive in a little bit into a systems engineering approach to making good decisions, and then applying that to the choice of programming language, which is something I've never seen done on a major project. These are 3 standards of systems engineering that you'll find out there. You find the ISO IEC 15288, which is quite popular in Europe. You'll find the Systems Engineering Fundamentals Guide from the U.S. Department of Defense, and then the CMMI handbook. Let's look at each of these in turn. They have common elements. So you'll see here, first of all, you decide how you're going to decide. You decide who needs to be involved in the decision. You identify what is your goal. What are you trying to achieve with this decision? You come up with criteria for determining whether or not you have achieved that goal. And then you arrive at an optimized decision, not a decision that's the best for some group or subgroup or somebody, but for the entire project as a whole. Okay, the same elements are in the systems engineering fundamentals approach. By and large, there's a few extra, 1 or 2 missing. CMMI is likewise has many of the same elements. Scrambled a little bit. You have this in your notes. So if you combine this, you can come up with sort of a consensus approach to making a decision, where you decide how to decide, you identify your stakeholders, you pick what your alternatives are that you're going to decide between, you develop your approach for making the decision, and then you come up with an optimized, you run the approach and come up with an optimized choice. Now, that is a good approach. However, if you now bring in the ideas, the lean principles, the principles that helped Japan, for instance, come from the point of bankruptcy right after World War II to the point of now being the world's largest automaker. If you apply those to this process, you get a better process. The first thing you do, in lean, stakeholders are almost all important. Those are the people that are affected by the decision. So we need to make some room and do a little more with them. So not only are we going to develop a list of stakeholders, we're also going to prioritize that list by their effect on the success of the program. And then we're going to ask those stakeholders, what do you care about? What's important to you? What in your mind makes this project a success? Now that we've done that, we can move part of strategizing down to after that decision so that we can take what we've learned from our stakeholders and use that to develop our criteria for making the decision. And then when we pick our alternatives, we can use what we have learned from our stakeholders to help us choose the best set of alternatives going into the decision. And that gives us what I would call a lean systems engineering approach to making this decision. So let's go through the steps in the process. First, how do we decide? Well, first thing we do is we decide that we're going to make the decision of what programming language that we're going to use on business criteria. And that's actually a fairly rare point of view. Then we commit to do it objectively. You know, you can still have subjective arguments about business. Well, I think this will help our business more. Well, no, I think that'll help our business more. Well, you're wrong. No, you're wrong. Well, I'm higher in the organization than you are, you know. And so it goes. So we commit to do the decision objectively rather than based on opinions or personalities. In this case, we've decided to use well-vetted, well-understood objective processes. And then you let the decision go where it will. You don't second guess it. You don't try to game the system. You let it go where it will. Step 2, identifying the stakeholders. Well, first of all, you come up with a list. Who can affect the success of this project? You prioritize them. Now, this is from a project I did, a consulting project I did for Lockheed in the UK. I won't say who the customer was, and I've sanitized the names there so that I'm not letting anything out. But the categories are there. It was a very interesting project, very political, the most complicated set of stakeholders I've ever seen. Government was involved, layers of corporations were involved, inside, outside the project, the public, various other users and customers, all involved. So we brainstormed. We sat down with the entire, a cross-section of the entire project and brainstormed who is affected or affects the success of this project. Who determines whether this project will be a success? And these were the folks we came up with. And we ran a technique I'm going to talk about in a minute to come up with these figures. And interestingly, this is what happens when you commit to take an objective approach. We discovered that the most important stakeholder for the success of the program was a consultant to the customer. If we could please the consultant, the customer would be happy and all sorts of other people would be happy. Totally counterintuitive, but that's what we discovered. And so you can see that now we have an idea of not only who determines the success of the project, but how important they are to the success of the project. How powerful this approach is. It has been used in all sorts of situations. It was used in the arms negotiations in Reykjavik back in the 80s. One of the early vettings of this technique was they had a number of light bulbs that had different brightnesses, and they had people, standing a distance away from the light bulbs, and they said, okay, so how bright are these relatively? And in the AHP, you'll see you do a binary comparison. So you take two items and compare them to each other. And so you do it 2 by 2 till every possible pairing has been compared. We'll get into that in a minute. When they ran that, they came up with the relative brightness of the light bulbs. Then they compared it to, because this is something that's measurable. They had, sensor. They measured it, and it came out to within a few hundredths of a % of the same. So it's an amazing technique. I mean, I like to say it's almost magical to take fallible, loose human judgment and to be able to turn it into something that's objectively right is a very, very powerful technique. And you can use this to resolve preference arguments because, again, the technique is reliable. Okay, this is the stakeholders that I showed in the previous chart. I've listed them across the top, and then for brevity, I lettered them and listed them across the bottom. So for the moment, ignore the green-looking cells and the blue-looking cells and just look at the white cells. What each of these cells represents is the comparison of two items, the item on the row and the item on the column. Now, the comparison is which is greater. A value of 1 says they're equally more important, or equally important to each other. 3 is 1 is weakly more important, 5 strongly, 7 very strongly, and 9 absolutely more important. Now, the order, if you see a number that is an integer, that means that the row item is more important than the column item. If you see 1 over the integer, that means the column item is more important than the row item. The math is not really important. What this is a approximation of an eigenvector to calculate the total importance of these items, relative importance of these items. The ones are where the item is comparing it to itself, which obviously they're equally important. The blue area is, you see the same binary comparison twice in the table. One with the, one item in the row and the other in the column. The other one is with the other item in the row and the first item in the column. So the blue items are just simply the inverses of the corresponding cells in the white area. So if you see a 3 in the white area, you'll see a 1/3 in the other area. Very quickly, you can find how to do this on the internet, plenty of descriptions. But quickly, you sum the rows, you divide every cell in the row by the sum to normalize the rows. Excuse me, I said that wrong. You sum the columns, sorry. And then you divide every cell by the column sum. So you normalize all the values in the columns. Then you sum across the rows, and you end up with a new column that has the sums of the rows. And you sum that column, and then you divide every value in that column by that sum. So you normalize that final sum of rows column. So I know this is too quick to really teach you, but I'm just trying to give you the flavor of how this works. And so once you've done that, then the values that are in that extra column out on the right are the actual weights of each of those items that are on the rows. Okay, so once you have prioritized the stakeholders, then you ask them what do they care about. Now this step is the least formal step in the process. You actually go out and you just interview people and say, what do you care about? What matters to you in the, what says to you that this project is successful? The CEO might say that I get quick profits from it. That would be a kind of a expected sort of a value. You go to each person's, you take your lists, you come back, and then you try to create one list out of that. Many times you will find that different stakeholders said the same thing in different ways. So you combine those, you come up with one list, then you go back to each stakeholder with that list and then go through the same AHP sort of a thing. So you have each stakeholder look at each pair of items in the list of values and say which is more important and by how much. You run the AHP, and then what you have is stakeholder by stakeholder, you have the importance of each of the items in the list. So for instance here, I've got an example. Let's say you have a stakeholder that's a CEO. When you ran the AHP on the stakeholders, you discovered that the CEO determines 0.5 or 50% of the success of the project. 3 values came up: quick profit, user friendliness, quick to market. Can be also technical type values as well. But so the CEO, when you ranked it with the CEO said, well, the work with the CEO said that the profit was worth 25%. Friendliness was 0.7 and speed to market was 0.05. These numbers are not intended to be real. It's just to kind of show you how you construct the decision. J Corp, maybe that's a distributor. The public, maybe that's the purchaser. Various values. Okay? Now, we want to come up with the weights for each of the values, stakeholders aside. Just how important are each of those values to the success of the project? That equation is really simpler than it looks. What it really says is you take the weight of the stakeholder times the weight that they put on the value plus the weight of the next stakeholder times the weight that they put on the value times the weight of the next stakeholder times the weight that they put on the value, and sum all of those. And that gives you the weighted sum of the weight of the value. You do that for all of those, and now you know, just like you have a weighted list of stakeholders, you now have a weighted list of values. When we did that on that project I was talking about, and when we collected the values into categories, it was absolutely fascinating. What we came up with, these are fairly common categories of priorities on projects. Customer satisfaction, system safety, reliability, quality, kind of lump those together. Project management effectiveness, and system technical performance. Now, if you just sit down and talk to a technical person, oftentimes what they'll tell you is that the technical performance of the system is the most important thing. Second most important is, well, we've got to have a good umbrella of project management or else we can't succeed, so that's second most important. Well, we do want quality in the product, so let's put some emphasis on that. And then customer satisfaction really never comes into the picture. Because, well, we don't have any contact with the customer, we don't understand, but we do have requirements. We'll develop to our requirements. When we ran this, and this was with the technical people up through the management on the project, same sort of people that might tell you that they really believe this, here's what the objective process showed. The exact opposite. What they really believed was that customer satisfaction was number one. It's exactly what lean production tells you. But people, if you just come and say, is that number one? They'll say no. But when you did all of the math and the binary comparisons and everything else, what that does is that ferrets out what people really think. It gets past the head to the heart. Strange thing, using math to get past the head to the heart, but it actually works. Number two, reliability, quality, safety. Number three, project management effectiveness. And a distant number four was technical performance. Because if you got a satisfied customer, if you're safe, reliable, you know, if it's not adequate technical performance, they're not going to be satisfied, are they? So it becomes a more distant concern. Step three, come up with requirements and constraints for the decision. This is only sort of as a last resort. This is the constraints that you put on yourself on your decision-making process. So, for instance, if you have a need to get the system out as soon as possible, tomorrow if possible, maybe you might put a constraint on your decision that your language, programming language, and support tools and utilities, you don't have time to self-develop anything, so anything you consider must come off the shelf. That would be a constraint on your decision-making process. However, the rest of the process really deals with issues that aren't ironclad constraints. So this is a place where that is all you consider. You may not have any. So picking alternatives based on stakeholder values. Well, first of all, if the project is large or long or integrity is an important value, you're going to be selecting from a list of statically typed languages, because there just is a lot more integrity in those, where the programmer declares the variable types and object types and so forth up front, and then that constrains the development from then on. Now, if that's not your development domain, as this quote says, you can hack things much better with dynamically typed languages. So if you're working in that domain, then these other types of things can go on your list and may actually be higher on your list than statically typed languages. Lists of alternatives, of course, are available all over the place. This is just representative. Developing the methodology, well, I am presenting a methodology to you here, which you could take as a basis, modify it, what have you, and use it. It's based on another lean technique called quality function deployment. And that is you use a series of matrices to make a decision. You can use it for many different decisions than this kind of decision, but this is one application of it. And I'm going to show you about the matrices starting at this point. So step 6, do the evaluation. Well, first of all, you develop a list of what language traits are important to you. So you talk to all your technical people, what have you. You come up with, what do they think is important? It doesn't have to be the right list. In other words, people can come up with strange language traits. It doesn't matter at this point. You just want to collect this list and condense it down again to a single list. These are some obvious ones that I think everyone here would probably agree are important. And I'm going to let Tony Hoare make the argument for me that integrity is one of the most important of all possible language traits. A broader principle here is to pick language traits that help you minimize system entropy. I think those should be on the list. And the idea here is that the most integrity the system ever has is the day that you conceive of it. You have this perfect idea. It's like the Platonic chair before you ever build the chair with all of its imperfections. The only thing that you can do as a developer from that point on is screw it up. So the idea here is you pick everything you do in development is to minimize that entropy of the perfection of that concept that you began with. And that can help you with picking language traits. You rank order the list of traits from the perspective of each trait. So of each, sorry, that's a misprint, of each value. So for instance, remember profit was one of the values in our list in our example. So you think, well, from the perspective of profit, what does that, which is more important, integrity or extensibility? What's more important, integrity or integrability? And so I said, this again is not an actual example. It's just to show you how to run the numbers. In this case, I said, well, integrity is strongly more important than extensibility and weakly more important than integrability, and what have you. So you run the same kind of AHP that we did before, and that gives you the values in this case of integrity of 63%, importance, extensibility 11%, and integrability 26%. So you do that with all of your values. You come up with for each of your values, you come up with a list. So here we go. From the perspective of the value profit, integrity is 63%, extensibility is 11%, integrability is 26%, profit was 40.5% importance. You do the same kind of weighted sum, and now you have a list of language traits and their weights. So integrity in your total list has an importance of 55%, and so forth. Now you have language traits. There's only one more step, and that is now to take the language traits and use that to help you select the languages. Same sort of an approach. So from the perspective of integrity, you do an AHP for the languages. You say, okay, so which is better for integrity, Java or Ada? Java or C++? Ada or C++? And so forth. You go right down the line, and we have a winner. It's Ada. This has nothing to do with the fact that this is an Ada conference. All right. So let's summarize the QFD process for making the language decision. So we started with the stakeholders, we prioritized them, and then we used that to determine the value weights. Then we bring those weights down, make that the rows. Then we use that to determine the language traits weights. We take those, and we use the language trait weights to determine the language weights. And now we have an objectively defensible choice of language. So repeating this, far too many software projects still fail. It's totally unnecessary. There's no excuse anymore. Language choice plays an important role in the success of projects. We can look to lean and systems engineering for objective, defensible ways of making decisions and getting free from the tyranny of people's opinions. I mean, that's good for everybody, even the people that normally tyrannize the other people. It's good for them that they're not able to do that anymore. We just went through a 6-step lean systems engineering process for making a language selection. And the result of doing that is that the project that's used on will have a stronger foundation for success. I'll make one more point here. To learn more, as John mentioned earlier, to learn more about lean software development in general, there is a free article that I've written that you can get through the web, and that's the connection, and that goes more into the overall lean software development process. All right, thank you.